Hey guys, this is Stinger from the Ghost Squadron Airsoft team, and today I'm going to explain to you how to go about rewiring your AEG and everything that's involved with that, including how to wire it to Dean's connectors or Ultra plugs. So during this video we're going to be rewiring my Wraith as an example. I currently have it set up in kind of an experimental mode where it has bullet connectors connecting the motors, and we're going to be totally rewiring it in the standard configuration with a MOSFET and dual signal wire setup. So to perform the rewire, you're going to need a few things. Obviously some wire. I recommend 16 gauge wiring. Now the way that the diameter of wiring is measured in the United States is using the American wire gauge. The way that this works is the larger the number, the smaller the diameter of the conductor in the wire itself. So smaller gauges are actually larger wires. Typically, for AEGs, most come stock with 20 gauge wiring, but most people who upgrade them put in 16 gauge wiring, or even somehow manage to fit in larger diameters than that. The improvement that smaller gauge wiring gives to you is that the larger conductor area allows you to pump more amperage through it with less resistance. It's essentially more efficient. So you're going to want to make sure that you have some good quality wire. The insulation on the wire also varies. You can get silicon or Teflon wire, which is called wet noodle wire. It bends very easily. You can also get plastic wires. There's a lot of different types. In this particular instance, I'm using some silicon insulation wire. I like it a lot just because of how malleable it is, and it's able to conform really well to the inside of the gearbox. Of course, you'll need something to connect the wires together, so you're going to need some connectors. Typically these come in two variations: Tamiya connectors, which are stock on most AEGs, and Dean's or Ultra plug connectors, which most people who are upgrading tend to use. Now Dean's is a brand name. Technically they're known as Ultra plugs, and that's what I will refer to them as. Ultra plugs are better in pretty much every way. Not only are they easier to connect, but they also have less resistance because they have a larger contact surface area, and they are smaller so they can fit into smaller spaces easier. They're just all around better, and they look much cleaner and nicer. You'll also need some motor connectors. These do break often, so I recommend that you get several. Another essential is heat shrink tubing. It's essential for a lot of things. It has many uses besides just electrical, but I recommend you get a wide assortment because you can use it in, like I said, all kinds of applications. You also need tools. In addition to the regular tools that you might use to disassemble your AEG, I would also recommend that you get some needle nose pliers and a pair of decent scissors for cutting heat shrink tubing. You'll also want some wire cutters and wire strippers because we're going to be doing electrical work. It's helpful to have a heat gun or a lighter, something that can make some heat to shrink heat shrink tubing. I believe that a heat gun is better just because it has multiple settings, has different uses, and it has much less likelihood to actually catch your heat shrink tubing or your wiring on fire, burn it, or otherwise melt it. Another essential is a soldering iron. It's an absolute must if you're going to be doing any kind of wiring inside your AEG. It's basically used to melt solder, which is a metal alloy that has a low melting point, and you melt it, and it is essentially used to adhere two pieces of conducting metal together. It's able to conduct electricity, and if you don't already know exactly what it does, I'll explain it later. Now, the first step to rewiring is going to be to disassemble, clean, and totally degrease all of your AEG. Break down the entire gearbox, pull everything out, clean it all off. You don't want there to be grease and dirt inside while you are trying to measure out wires and solder them together and stuff like that. Now, in the case of my AEG here, I've already set it up in a dual signal wire configuration to the MOSFET, which is a gate nano ASR, and that means that I do not have any power carrying wires going up to the trigger contacts. Now, if your AEG is stock, most of the time it will have power carrying wires going up to the trigger contacts. What this means is that if you want to set the AEG up in a double signal wire configuration, you will have to unsolder those power carrying wires from the trigger contacts. So that is essentially the first step for you, is to disconnect all wires from everything. You should just have only the wires and have the trigger contacts and gearbox, motor, things like that, all without any wires connected. Now for a moment I just want to talk about MOSFET configurations, because this video is going to assume that you are putting in a MOSFET along with all of the rest of the wiring. So there's two types of MOSFET configurations, the single signal wire and the double signal wire. Now I have a separate video explaining how exactly a MOSFET works, but to simplify it a little bit in this video, the single signal wire configuration has a wire going up to the trigger contacts that does not carry power to the motor. And it has another wire traveling up to the trigger contacts which does carry power. When the trigger contacts are closed, electricity is sent across that signal wire, and that tells the MOSFET to open up power to the other power wire, which runs straight down to the motor from the MOSFET and does not go to the trigger contacts. This is the most commonly seen setup. However, it's not the best setup. The best setup is the dual signal wire setup, where you have two signal wires which do not carry power going up to the trigger contacts, and each one is on a separate contact. So what happens when you pull the trigger is a circuit is made across both of those signal wires going to the MOSFET, and then the MOSFET immediately dumps power through the power wires which run straight to the motor. And this gives you a much cleaner and faster trigger response. It also makes all of the wiring up by the trigger contacts very neat, and means that you can remove the power wires without having to remove the trigger contacts. So the next step is going to be to measure out the wire. Now, if you are using a single signal wire setup, you're going to have to do this a little differently than I'm going to show here. What I'm measuring here is just the distance from the connector that plugs into the MOSFET down to the connector that attaches to the motor. Some things that you will need to keep in mind are that the wires plug into the top of the motor, which is the furthest point away on the motor from the gearbox itself. And also the positive wire will have to be slightly longer than the negative wire by about 2 centimeters, as it has to go up, over, and around the top of the motor. Whether you measure and cut the positive or negative wires first does not matter. However, if you are doing a single signal wire setup, I would recommend that you measure out the positive wire first from the MOSFET to the trigger contacts, and then from the trigger contacts down to the motor. Keep in mind that the signal wire in a single signal wire setup is alone on its side of the trigger contacts, and you will have two wires soldered on, both positive, up at that single trigger contact. And with a dual signal wire setup, you'll just have the power wires running straight from the MOSFET to each side of the motor, and then the signal wires running from the MOSFET to each side of the trigger contact. Once you've measured and cut the wires, next step is going to be to attach connectors. I like to attach the motor connectors first, just because if you make a mistake, it's easy to redo, and wiring in the motor connectors does not attach the positive and negative wires together, so you can always just redo it very easily. Motor connectors are technically supposed to be crimped. However, I do not have a crimping tool, and most people that do this do not, so what they do is solder them on. As you can see, you have to strip insulation off, make sure you measure it right. It should not go up inside of where the terminal will plug into the connector, just along the stem of the connector. You should have bare wire, and the first set of crimping tongs are supposed to go around the wire's insulation. The second set of crimping tongs are supposed to go on the conductor of the wire itself, so make sure you measure that appropriately as well. I use needle nose pliers to kind of crimp the little tongs down, just so it attaches fine by itself before I solder it, and then after that I put it in a vise and I solder it. Now, my method of soldering is to put the soldering iron up against the connector that I'm soldering it to, and this transfers heat onto the connector and the wire. Once the connector and wire are hot enough to melt solder, I press the solder against the connector, and it provides a very, very clean solder joint, as you can see. Once you've applied the solder and let it cool, you can remove it from the vise, and the next step will be to put some heat shrink tubing over it. Now, what colors you use are your choice, but I would recommend that you color code it properly. So if it is going to be the negative connector, you use black heat shrink tubing, and if it's going to be the positive connector, you use red, green, or yellow heat shrink tubing. You simply have to slide the heat shrink tubing over the connector and then apply heat. Like I said before, I'm using a heat gun. It's very easy, but you could also use a lighter. Just be careful not to burn the heat shrink tubing or the insulation on the wire. So once you finish with the motor connectors, you're going to need to solder a connector onto the other end of the wires. Where you do this is entirely dependent on how you're going to set your AEG up. With mine, since I'm using the gate MOSFET, I'm going to wire a Dean's connector onto those two wires, which will then plug into the MOSFET. Some MOSFETs may require a direct connection, so you might have to solder the wires directly onto the MOSFET. Obviously it's going to be a little bit different than what I show, but the concept will still be the same. So now I'm going to show you how to attach an ultra plug connector. Much like with the motor connectors, you're first going to have to strip off about a centimeter of insulation on the wire that you are soldering, maybe a little bit less. Just enough of the conductor of the wire needs to be exposed to fully cover the top of the connector that you are soldering it to. You should put the connector into a vise or some sort of other object that can hold it. Something you need to keep in mind when attaching an ultra plug connector is that you may not be able to get the heat shrink tubing on it after you've soldered it, because of course you've soldered it on. In our case, just because the motor connectors are on the other end of this wire, we can solder it and then just work the heat shrink tubing all the way up to where we soldered it to the ultra plug. But for example, if the wire that you were connecting had another ultra plug on the other end of the wires that you already attached, you wouldn't be able to run heat shrink tubing up to it. So just put the heat shrink tubing down the wire before you solder it onto the ultra plug connector, if that is the case. Like with the motor connectors, my method of soldering is to have the two pieces of metal that I am soldering together already touching each other. I use the soldering iron to heat those pieces of metal up and then press the solder against pieces of metal that I'm soldering once it's hot enough. And that will melt the solder, it will flow around, and then I let it cool. Another thing to keep in mind is that the connectors on your AEG should always be male connectors if they plug into a battery. The reason being is that you do not want a male connector on a battery because it presents the possibility of short-circuiting the battery. So once you have both wires soldered on, I would recommend that you put some sort of heat shrink tubing around both of the wires as well. The reason for this is because solder flows down the wires underneath the insulation a little ways from the solder joint, and once that hardens it becomes very brittle and it can be easily broken if that is bent. So you want to reinforce the area where the solder joints are, especially where the two wires that you soldered come together. Alternatively, you could use electrical tape to do it as well, however I just like to use several layers of heat shrink tubing. At this point, you can test to see whether or not your wiring setup works just by plugging the motor connectors into the motor and then plugging a battery into the MOSFET or whatever connector you have on that side of the AEG and pulling the trigger. Make sure you hold the motor, otherwise it will just spin out of control and bounce all around. Just pull the trigger, hold it, see if it spins. If it does, obviously the connection is solid. Now, in my setup, the wires that come out of the back of the gearbox have to contact an area where there's threading with the buffer tube, and this can often cause the insulation on the wires to be cut open just by the threads that are there when I screw and unscrew the buffer tube. This doesn't apply to all AEGs, but just for mine, I like to reinforce that area of wiring by bundling it all together inside of a single layer of heat shrink tubing that will protect it. I would just recommend you look for similar areas in your AEG where the wires may be at risk for being damaged like that, and then reinforce it with heat shrink tubing. In the case of my Wraith, I need to have another set of wires going from the MOSFET up through the buffer tube to where the battery is going to plug in. So I also have to make another set of wires which have a female ultra plug connector on one end and then a male ultra plug on the other end. Obviously your AEG may be different, so just make sure you measure the wires properly when you do this. You may not need to do this at all. Alternatively, you could make the wire coming out of the gearbox long enough that the MOSFET is what the battery plugs into. I just personally do not like doing that, but it is another option. So for this, I just measure out the wires appropriately, make sure I leave a little bit extra. It's always a good idea to leave a little bit extra wire, and then I solder the ultra plugs on, heat shrink tube the whole thing up, and it's good to go. reassemble all of the parts of the gearbox. Make sure you lubricate them as well. If you have a version 2 style gearbox, you can test it without reassembling the entire gun, as I show here. Same thing with the V3. I would recommend you do that just because it is always a bad feeling to assemble the entire gun and then test it just to have it not work because of some simple thing that you forgot. So I would recommend that you test it before you totally reassemble it. If it cycles well, then it's good to go. Reassemble the entire thing and test again. And if that's good, then you've succeeded in rewiring your AEG. Thank you guys for watching this video. I hope it was informative and helpful. If you want to see tech videos on another topic, please recommend it down in the comments, and I will try and put it into my very long list of topics to cover. Hopefully sometime I'll get around to actually making it. Again, thank you for watching this video, and I'll see you guys later.
Let's go, let's go, let's go.